high-level design. So pretty much what we're looking at is in requirement, we are trying to look at the system from outside. Basically, enumerating the features you have to implement and made available to your users. That user is abstract, can be a human being, can be another machine, what have you, can be another software program. So essentially, the functionality you provide to outside users. So you don't look into the system, but you look at the requirements. Once we talk about analysis, a little bit different. We're really looking at high-level modules of our system that need to be we need to implement all the features they identified in requirement. Okay, so just keep those key things in mind. So this Thursday, you have two things due: your requirement document and your first homework. You don't have. You may say, "Oh, I'll do it on the same day." That's bad. That's exactly why we have the late days for you to shift your work later for 1 day, 2 days, or 3 days, right? So it's up to you to use those late days. Requirement document is very straightforward. We have a template on the website, but it's only a template, okay? I'm not looking for you to fill out all the content, okay? That is basically kind of like a superset, okay? So you will have that handy whenever you need to create a requirement document of any sort. You can pull that template out and say, hey, I'll see what components in that document template is useful for me, right? Main thing for you to fill in is the keys. You pick what you think is necessary. In our case, our system is so simple. What you're looking for is your high-level use case diagram, and basically a description of each use case. That's what we're looking for, right? We're looking for so you are able to enumerate. Basically, it's very simple. We have that text, half a page. I'm actually looking at whether your use case diagram and your text cover that text or not. I'm basically going to lay your text on top of that, your use case diagram on that text, the text. If I see this, I'm happy, right? If I see this, I'm not happy because you are leaking information out. Basically, you're losing information. Make sense? For instance, if you identify 5 use cases, have you covered all the functionality we're demanding from your system by those 5 use cases? If not, point deducted. If yes, you got your point. Simple like that. Because you can't leak any information. Leaking information, leaving things on the table means that you're not going to deliver the right software for the customer. Questions? This is our grading criteria. Okay, I'm just going to take the half page, take your diagram, and map looking for misalignment. If it's right, perfect, you got a grade. If it's not aligned, okay, you got point deducted. Go ahead.
What do you mean by leaking information again?
So for instance, if there is a functionality in the original description, I cannot find a corresponding use case which cover that functionality. Basically, you left information of the original description there. You're not implementing. That's a good clarification question. Make sense? So basically, your use cases should cover all possibilities with this system. If not, you're losing points. Questions? Make sense? Make sense? Make sense for you? For you? How are you, Jason? Yeah? Make sense? Very simple. I'm just going to take your document, your use case diagram. If I look at your use case diagram, I can already decide whether I'm going to give you a point or not. Pretty much. I'm seeing, oh, yeah, you have the 5 use case, all these things covered. Nice. Pretty much you're done, right? Then if I need more information, I'll go to your detailed description of those step-by-step of those use cases and see what's going on, right? For grading, it's very straightforward. It's about coverage, right? Have you covered them all? If you've not covered all the So I'm the user, I'm paying for you to get this system done, and you come to me and say, only going to do four features for you, not the 5. Then that's not acceptable, right? Same thing happened here. We want you to cover all the functionality of the system. You have to cover them all. By use case diagram, I will be able to have an overview of what's going on. Okay, so let's go directly into our lecture. Right? So this is the use case diagram. Ooh, okay. I should have to use the other way. So first I'm looking for this, right? You can say, oh, I hate the use case diagram. Yeah, but you only need to use this once in my class. Then you'll find your best way to represent your requirement later on, right? Whatever you like. Not my problem anymore, because I already give you the training. You are able to do that. You show you are able to do that. You can go out of the door and find your job and say, okay, I totally hate use case diagram. I'm not going to use it in my life. That's okay. You can use user stories, right? All other kind of good stuff. That's your choice. But you have to demonstrate you are able to solve a problem with the technique like this. What I'm looking for in your requirement document is, do you have a diagram or not? Right? If you don't have a diagram, I'm not saying I'm not going to give you a point, but this will help me understand your requirement much easier. I have a very high level overview of what have you thought about all the points in the requirement. Okay, very straightforward to see. Go ahead.
Is there a use case diagram for each use, or this one has 2 uses? Like
This is a use case diagram with 2 use cases.
Yeah.
Yes.
So
you only need 1 use case diagram
Okay.
with all the use cases listed. Okay? So for your use case diagram, just one single page, 1 single figure, more than enough. You don't have that many use cases. Okay, you have login, create new users, right? Send a message to a single user, send a message to every user, retrieve your chat. Okay? A few more maybe, as you design. I'm not going to enumerate them all, but that's part of your job. But pretty much you're very close to that, right? Then you have to write down step by step of each use case. Okay, then you're done. Okay, I don't think the requirement document will actually take you that long to finish. Go ahead.
So our use case diagram is going to be something like this.
Yeah.
Just like high level, all of those 5 functionalities.
Yep.
And then in our requirements document itself, that's where we list what the use case means.
Yeah, each use case, right? So you have your overview. Okay, this is my use case diagram. We have 5 use cases. Okay, now I'm going to run down for each use case. What's the use case name? What's the high-level overview of that use case, and step by step. Okay, this is the same thing you will do for any project. Okay, you can use a user story, what have you, the same thing. You cannot escape this because you have to break down this information one way or another. You can say, I never use use case diagram, I hate it. That's okay. Then you have to have some way, some other people will be able to understand as well. This happen to be, I mean, everybody can understand almost. Questions? Our requirement document is actually not that hard. Just need to be clear. I assume now everybody is clear. Everybody is clear about what to deposit to the D2L folder by Thursday. Okay, all right. So basically, here is, this is actually the handshake between your requirement stage and your analysis / high-level design stage. This is looking of the system from outside. Now we are diving into the system, right? Diving into the system is then first step, we refine the scenario into normal situation, exception situation, and what have you. Then we start identifying classes. Because in object-oriented design, Java, C++, right? Almost every object-oriented language the basic building block is class. Okay? So your job in high-level design is to first identify classes you need in your system. These are components of your system. If you're dealing with a bigger system, much bigger system, you have modules, packages, those things group several objects together, or many objects together. That's just a hierarchical thing. Okay? Those things are not necessary. You can have a single system which have 1,000 classes, which implement the system functionality. That's a design. May be a bad design because you don't have hierarchy, but it's a design which can work. Okay? So that could be a system that's working. Just that not elegant, probably hard to, very messy to maintain and everything, very hard to assign people to work on. It's really hard to organize a team that way if you have such a flat hierarchy, right? So that's why, just like all the startup company when they start, they have very flat company hierarchy, but once they grow bigger and bigger to a certain size, they build out hierarchy. They have to, otherwise they would not be able to manage so many things. Same thing happened here. For your system, I mean, you're counting the number of classes by hand. Okay? Maybe one single hand would be sufficient, right? So do you really need another level of hierarchy for this? Probably not. I mean, so my son, who is in preschool, can already do this. Okay, I can manage 5 things at the same time, right? So in that case, you don't need a hierarchy, right? So essentially, once we move into the system, our goal is to be able to identify the classes we need to implement all the features. Okay? Then remember we have 3 types of classes. Okay? 3 types of classes. Entity class, basically is your information store. So you hold on information, it will be there for you to retrieve, save to, and retrieve from. Okay? Then you have your interface class, which basically is your interface for users of all kinds. It can be a machine, can be a program, can be a real human being, right? And the last one is computation, right? Essentially, computation is what you do about those data. So in our discipline, this is the core. Okay? If you don't understand any other model, this is the model you should understand. We are all about data and how to process data. No exception. You need a way to store your data permanently, like your files, right? If you don't have a permanent way to save your file, then you may miss the deadline to submit my requirement document, right? We are in the business of permanently storing information and process that information. I mean, Facebook is a big data storage site. And they also provide you a way to process the data. You process the data, and they process the data as well. Okay? Google, same thing. It's a search engine by default. It's basically a big data store. You provide your functionality of search. At the same time, give you more information you don't really want, but yeah, you pay for it, right? So Google is basically a big. So do you know actually when you type in that search, Google is not actually searching for you. Google basically is say, okay, I have this copy and here you go, right? So you're not going to really, when you search for something, it's not Google going to my website to search for my information, okay? If Google does that, it will take you a long time to get the search result back. Actually, all the information on internet, you can find, you can index, you can crawl, actually are stored in Google's own database. Okay? So for instance, when we do this search, let me see, what they, so my previous search is myself, okay? Obviously, right? When I search this, okay, I'm typing in Chrome, nothing goes out yet. My type goes to Google server. This information is not coming from my website, okay? Directly. This has been cached here for days. Okay? This is from Google's database. And only when I click on this link, this is actually going to my real website. Okay? So actually Google cache all this information so they can do the search locally. And most of the time, because I searched this a couple of times, this is already a buffered search at Google. Every time they basically say, oh, you're searching for this, here you go. The search result is this. They already pre-processed. That's why it goes so fast. Otherwise, yeah, it take a long time to get that information back. So pretty much, your Google is a big data store. Just like you. You are tasked to save somebody else chat history, basically. Collect their chat history, keep their chat history, and for them to retrieve their chat history. That's it. You're processing data. The data is your chat information. I mean, you are in the same company like Facebook Messenger, Twitter, Instagram, and WeChat, and what have you. You're in the same business, just that nobody uses your business, so you don't pay you, right? That's the key difference. But you are in the same business now, saving messages, propagating messages, and retrieve messages. That's it. So you need an entity class to save your information. You need an interface class so that you can share that information with something. If your system has no interface, that system is totally useless system. It's just wasting energy, right? Like so just many people think that Bitcoin is totally waste of energy. The only thing that's happening there is wasting electricity, nothing else. For some people to believe, right? So certainly many of us may think, oh, it's actually worth something, but it's also a data storage and the processing system and interface system. Think about it, right? If you have a Bitcoin, right, $3,000, $5,000,
That's a lot.
right? So if you, good luck if you have one, right? So if you $5,000, it needs some way to store that information somehow. It's has a complicated scheme to store that information, and so that you can retrieve that information and say, that's my Bitcoin, right? Okay. You better hope that is a entity class, right? Otherwise, you will lose your money. You better hope. So then you have computation of mining Bitcoin. You have computation of sending Bitcoin to somebody, right? Or buying something, or those are computation called control class. And you better have an interface of some sort. You can look into your Bitcoin. Otherwise, what's good about it, right? Even for complex system like Bitcoin, same as the system we are building here, same concept. Yeah, entity, interface, control. That's all. No exception. That's why our class is so fundamental. It's called 300, not 600, because this is actually foundation to everything. The view is foundation to everything. Here you basically, this is the foundation of building any software system. You need data storage, you need processing, you need interface. Your job is to start, be able to take that small spec and decide what should be entity class, what should be interface class, what should be control class. Okay, that's essentially your job. All right, so as we know that for information is typically associated with nouns in languages. That's why if you anything else failed, all the method all those automation you have tried failed, this is your chance. You just say, okay, I'm going back to grade school and partition this paragraph into tokens, and then I'm going to use a very simple way of list them all and decide on one by one whether there should be a class or not, or should be an attribute or not. Okay? So this one everybody can do. If anything else failed, you can say, oh, I have a great insight, I have a great instinct. I'm just going to directly jump into, I'm just going to write out the entity class, write out the control class, and write out the interface class. Great for you, okay? After years of practice and working, you will be there. But if anything else fail you now, this is your friend, okay? Go for the nouns, for the information you need to store. Go for the verbs, for the control you have to do, right? That's it. How hard it can be. This is how you analyze the English text, which you learn in grade school. Same things, you apply the same skill here. The most fundamental way to decide what are the information you are storing, what are the actions you're taking. That's the same way our language, our English language specification has the same ingredient, right? So information is stored in that text. The action is described in that text. So it has all the information. That's why I'm saying your requirement document should cover everything in that document, because all the information is there. All right? So if anything fail, you can always come back to this approach and make your headway to a pretty poor design. Although it's a poor design, it's a design. A poor design doesn't mean it's incorrect, right? Just not optimized. May have a much better version for it. But before you have an optimized version, you better be able to come to a not so optimized design. That's the point. Okay? You can always achieve this goal by noun analysis and verb analysis. Okay? That's how you actually deal with this problem. All right. With that, you can say, oh yeah, I'll come to identify the classes and what their relationship. Basically, these are the verbs that you actually can